Hello class, this is CSE-4400, Section 1, Week 10, Fall 2025. We are missing a few chapters, and I will have to cycle back to that on account of we just had a few weeks where we had check-ins and playtesting. Yeah, we're going to have to cycle back to that material in a little bit. That is all about storytelling, characters, and to an extent, creative and expressive play, but also level design. We're gonna have to cycle back to level design as well. So my apologies for missing those chapters. We'll have to cycle back to that. For now, let's look at chapter 12 and the user experience. So there are two similar terms, the user experience and the user interface. So the user interface, that is the thing that receives user input and sends it to the game's core mechanics. The core mechanics then sends output to be displayed so that the user can see that output. So the UI defines the player's experience, and it has an enormous effect on how the player perceives the game. There's a similar term that I brought up, and that is user experience. This is something that you might be more familiar with if you have already taken, say, software engineering. This is something that only exists within the player's mind, but it's... Yeah, so the UI exists between the player and the core mechanics. The user experience exists within the player's mind. It's something that is related to the user interface. So, we're going to look at how we're supposed to create the user experience. So remember that the user interface is the intermediary between the player and the core mechanics. The player sends inputs to the user interface. The user interface sends that as actions to the core mechanics. The core mechanics sends challenges to the user interface, which then outputs it to the player in the form of audio or visual output. And this is something that we talked about earlier in the course as well. So the inputs controlling the UI are called control elements. The outputs of the UI are called visual and audio elements. There is a chicken and the egg situation when discussing UI. You can't learn how to make a good UI without knowing the names of common visual elements, and you can't be introduced to them without making references to how they're used. The thing is, there's a good chance that you're familiar with like 90% of all the common UI elements already. So we're just gonna go forward anyway, and we're gonna talk about principles of interface design and visual elements. So remember, throughout the course we are looking at player-centric game design, making a game that a representative player would enjoy playing while also having the game be a commercial success. So again, most of us have a general idea of what a UI even is. Because, well, we see all sorts of programs already in our day-to-day lives, not just video games. Most programs, however, are tools, so their interfaces allow the user to enter data, control processes, see results, and for many of those programs, they're also customizable. When it comes to video games are not tools. They are not like productivity software. Certain aspects of a video game cannot be presented to the player because if you do, you'll take away the challenge. To that end, you also design the user interface in line with whatever challenges the player may experience in your game. So if you have a driving game, for example, you want the user interface to feel like it is a driving game. Maybe you want to have a gauge cluster. And on that gauge cluster, maybe you want to have a fuel indicator, or maybe you want to have a steering wheel as well. If you are playing some sort of live action game, maybe you want to display a few basic things about the player's status. Maybe you want to have a health bar. Maybe you want to have a mana bar. Maybe you want to have a stamina bar. maybe you also want to have a few slots for quick access items, like a health potion. So the player-centric approach also applies to UI design. Therefore, we want to focus on what the player needs to play the game well, and how to create as smooth and enjoyable an experience as possible. A little bit to talk about as well. When we talk about things in storytelling, common themes are basically copied from a copy from a copy from a copy. To quote the Bible, there's nothing new under the sun. It's at a point where many storytelling themes and settings have been borrowed to the point that they're basically cliche. So, when we talk about storytelling, you are basically encouraged to innovate there, if possible. However, none of that applies to interface design. Many games have evolved their UIs to the point of being standardized, and players expect that familiarity. If you want your game to have a UI that works, you're gonna want to borrow from the best. Because chances are, it's their UI. If you're going to turn to games for inspiration, if you want to make something that works, borrow from the best. Oh, let me go back. So as a design rule, if you try to innovate UI design, you might needlessly frustrate the player, no matter how good the rest of the game is. If you do want to try something new, try it out and playtest it. And if it doesn't work, go back to what does work. So let's talk about a few general principles that you're gonna want to keep in mind. Regardless of genre, be consistent. Your game should be stylistically and operationally consistent. Give good feedback. When the player interacts with the game, the player expects the game to react, even if it's the sound of the Minecraft UI buttons clicking noise when you click on a button. Remember that the player is in control. Don't force the player or the player's avatar to do something that they don't want to do. Limit the number of steps needed to control an action, unless that is part of a combo move. Otherwise, limit yourself to around like 3-ish button presses at most to perform an action. That includes navigating through nested menus, if possible. Some games can't really avoid that though. Also, permit easy reversal of actions, unless doing so adversely affects game balancing. Some games let you undo things, other games don't give you that luxury because, well, it's a real-time, maybe it's an MMO and you can't undo in that way. Also, minimize physical stress. To play a video game can tire a player's thumbs or hands to the point that players can get repetitive stress injuries just from playing a game. Or maybe they play a video game with a controller in an unorthodox way, and it basically forms calluses on their hands. That's something that was brought up to me in class. People play with controllers in an unorthodox way, operating the joystick to the point that they get calluses on their palms. Don't stress the player's short-term memory. If there's something that the player must remember, have it be on screen. Group related stuff together on the screen. I'll have to show you what... Okay, so for that, if you have a health bar and a stamina bar and a mana bar, chances are you're gonna want to group all of those together, so the player has to look at one place and they're all there together. The player should not have to look at 3 different locations to find out what is the state of the player. If you can, provide shortcuts for experienced players. This includes the ability to change keybinds and the ability to add new keybinds. This does not necessarily apply for very simple games, though this is something that I personally wish a lot of big games do. And for many of them, they do have this feature, the ability to change keybinds. Because I don't use a QWERTY keyboard, and I haven't for the past decade and a half. Decade and a half? Roughly about that much time. I've typed on a Colmac keyboard for at least the past 10 years or so, and instead of WASD, it's WARS. If I keyboard mash, you're going to be able to pronounce everything I say, simply because the home row has 80% of all the values you'll ever need. It's not Astafgjikel semicolon, it's Arsthneo. ARSTDHNEIO. If you just made random strings using only those letters, you're going to have something that's barely pronounceable. No, not just barely pronounceable, perfectly pronounceable. Because Astafgjikel, good luck saying anything out. Good luck saying anything when all you have is one vowel. Anyway, that's a bit of a divergence. But yeah, the ability to provide keyboard shortcuts to experienced players. This is more for complex games. For very simple games, don't worry about this. But if you're not able to provide the ability to change WASD to something else, at least offer a means of using the arrow keys as fallback. Because, well, not everyone types on a QWERTY keyboard, and when you consider European languages keyboard layouts, yeah, you're going to want to be able to at least fall back on some other means of input. Okay, so what does the player need to know when they play a video game? What information should a video game display to facilitate, hey, am I doing this thing correctly? Am I doing the right thing? Am I winning? So consider the following questions, and then step back and see if you can find the corresponding elements in this mess of an image here. Where am I? Well, we can answer this by providing a minimap, or if a minimap would break game immersion, some sort of map interface that the player would be able to at least open in some sort of menu or something. So that's one way to answer the question of where am I? What am I doing right now? Provide something, even if it's a quest book that the player must open through an interface, to indicate what the player is even supposed to be doing right now. Did my action succeed or fail? If this is the kind of game where you just beat up bad guys, the most immediate indicator is just the bad guys falling to the ground, playing out their death animations. That's the easiest indicator you can give if your game has any form of combat. Or, put the other way, your player undergoing a death animation because you died. Or rather, your player avatar died. Do I have what I need to play successfully? This includes things that would be placed in a game's hotbar, so you can know how much of what things you have. Ammo, potions, energy, mana, stamina, whatever you need to play a game successfully, to surmount whatever you need to surmount against challenges. Am I in danger of losing? This is easy to represent. Depending on the context of the challenge, you can represent this as a health indicator, or if it's a timed challenge, a countdown timer. Am I making progress? Okay, so this might also overlap with the am I in danger of losing. In Pokemon Go, when you take on a Pokemon raid, you actually have two indicators. The first one is the health of the Pokemon that you're trying to defeat, and the second one is the countdown timer. Both of those are answering two different questions. Am I in danger of losing, and am I making progress? But they're kinda interlinked, because am I in danger of losing? Well, we can answer that by determining whether our time is low and the Pokemon's health is still high. that is when you know that you're in danger of losing. Am I making progress? Well, all I gotta do is look at the Pokemon's health bar. For other tasks, like a quest in an RPG, you can show this in other ways, such as a percentage of a task complete, or a checklist of tasks to do and tasks already completed. What should I do next? For a racing game, this can be in the form of road signs that point you which way to go. For an RPG, this can be in the form of a list of NPCs to visit. In Pokemon Go, there is a icon that you can press that shows things that you can do. Oh, and finally, how did I do? If you succeed at doing a Pokemon raid, you're going to get some sort of score, and you're also going to get some amount of rewards. That's your biggest indicator of, okay, I did well. But if you ask me, the biggest indicator is whether your Pokemon is 3 stars. Because for a lot of mobile games, there is this 3-star rating system that goes from 0 to 3 stars, and Pokemon Go is no exception. Oh, and finally, don't taunt the player, or at least don't needlessly taunt the player. If this taunt is gonna be coming from a particular enemy NPC, and it is on character for that NPC, yeah, that's gonna be a reasonable taunt. But so the book says don't taunt the player. I would tweak that slightly and say don't needlessly taunt the player. The player's already gonna feel bad for losing a challenge. Don't make it worse than it needs to. Oh, and by the way, this is the full image for this mess of UI elements everywhere. And my webcam is blocking some of that, so there's some more even here. So yeah. Even though this interface is an absolute mess, see if any of these elements answer any of the questions that we just discussed. Anyway, what the player wants to do. So we have what the player needs to know, but also what does the player want to do? The player wants to know things necessary to play a game, but the player also wants to do things within the game. So the things that a player can do is going to depend on the game and the state of the game, but there are several actions that are common enough that you may as well just call them universal. Such as move. Nearly all games provide some sort of movement, unless this is a menu-based game and the player doesn't move per se. Look around. The player can't see the whole world, so they just wanna move and look around to explore what the world looks like. This is assuming this is a video game that has a game world to explore, interact with NPCs. This includes combat with NPCs you can fight, and non-combat actions with NPCs you can still interact with, like trade. Move portable objects. Simple enough. This can be as simple as moving a chess piece on a chessboard, or picking up rocks in an adventure game. Manipulate stationary objects. There are some objects that cannot be moved, but you can do other things to them, like turn on and off a light switch. Construct and demolish objects. This is closer to games where you can build and destroy stuff. Conduct negotiations and financial transactions. Basically, that's closer to trading and more in line. In the simplest sense, this would be something like trading. In the more complex sense, this has to do more with simulation games. Give orders to units or characters. So this also depends on the game. Some games have a party system where you get to command certain NPCs to move around a board. Have conversations with an NPC. So some NPCs you can interact with by having a conversation with them. Any sort of conversation with an NPC is almost always a given, and it's typically done with a dialogue tree. customizations. This has more to do if a game allows you to customize the appearance of your player or avatar. So, changing their hair color, but also may involve changing attributes that actually matter. Like, this piece of armor gives you like plus 10 dexterity, and you want to swap it out. Talk to friends, which applies more to online games. And then these four options are basically self-explanatory: pause the game, though some games cannot be paused; set game options, save the game, and exit the game. Okay, let's talk about the design process. So, we should be here, somewhere in the elaboration stage. So, we should, by now, I assume most of you have long since moved on from the concept stage and are currently in the middle of the elaboration stage. At some point, we're going to exit and enter the tuning stage, but we're not quite there yet. Maybe by prototype 2, we will be. So recall that game design is a 3-step process involving concept, elaboration, and tuning. When you design your UI, it's going to be early on in the elaboration stage. So when you did your first game design document submission, you may have only had a vague inkling of what your UI will be, and many of you actually added descriptions of what your AI or of what your UI should look like, which is good because we actually need that information for setting up the user interface. And for many of your games, there was already a user interface, which is also really good. It means now you have something to work with and something to tinker with if you feel like it's not working out. Well, but that's the beauty of iterative design. We can make something work, try it out, and tweak it if it doesn't until it works, or throw it out and make something else that does work. We're gonna now look at the steps of designing the UI, but note, if you are working with a large team, the lead designer and UI designer are going to be two different people, but for small teams, we're going to assume that these two roles are served by the same person. So here are the 4 steps. Define your gameplay modes, choose a screen layout, tell the player what they need to know, and let the player do what they want to do. So you gotta define your gameplay modes. If you only have one gameplay mode, this step is now basically easy mode. For those kinds of games, you only have one interface to work with, though some games will have more than one gameplay mode, such as when you have a game, such as a racing game, where in one mode you're racing, but in another mode it is a pit stop minigame. So you need 2 separate interfaces to facilitate those 2 different sets of actions. A gameplay mode consists of a camera model, an interaction model, and the gameplay available. So let's go back to that example of a racing game. Maybe in that racing mode, it is a first-person view, and you're looking through the eyes of the driver. To facilitate driving, you're going to need an interface that looks like the driver's seat of a car, gauge clusters and all, and maybe even rear view mirrors. To facilitate that pit stop minigame, you're probably going to need to operate certain tools. So, bye-bye gauge cluster, hello toolbox maybe. Remember, not everything the player can do is displayed, and to that end, we use different gameplay modes to facilitate related actions. So, the user interface for the driving mode would include elements such as a steering wheel, rear view mirrors, and a gauge cluster. The pit stop minigame would include things related to a pit stop, maybe a toolbox that you have to drag and drop to certain elements of your car. Whatever you do, you're going to want to define your primary gameplay mode. So it's that racing game that I'm bringing up as an example. The driving mode is going to be your primary gameplay mode. You're going to want a camera model, which in this case is going to be a first-person model, and you're going to also want an interaction model for it. we're gonna have to talk about that in a little bit. In the mode for the pit stop minigame, you still might be okay with a first-person camera, but the interaction model is going to be different. Again, we'll have to talk about interaction models in a little bit. Sometimes when you have a game with multiple game modes, sometimes there's very little differences in the appearance of the UI, so you can just get away with swapping certain elements out for one another. So this is why it's a good idea to define all your gameplay modes first, so you can define what common elements there are and make things a little bit easier for yourself by just switching different UI elements based on what's going on in the game. If your game has a lot of gameplay modes, it's better to wait until after you've documented your game structure. And the game structure, that is a flowchart, state diagram, storyboard combo wombo that describes your game's game modes and how the game transitions between different modes. Once you got all that, think about what visual elements and controls each mode needs. In some games, multiple gameplay modes share the same UI and only differ by the challenges offered. This is what I mean by changing very little between different gameplay modes, because sometimes the only things that change are just what buttons are available there are for the player to push. So the steps for designing a UI are as follows. Design a screen layout and then select the appropriate visual elements. For designing a screen layout, let's also ask the question of how do you choose a screen layout? Basically, windowed or full screen. Whatever you decide on, you're going to want to find a balance between how much screen space the game's main view is and how much space everything else takes up. If your game is going to be a desktop game, for the most part, that's going to be a non-issue. We have large, high-resolution screens, at least 1920 by 1080 pixels. That's about 2 million pixels. So even if you have to downgrade and go to 1366 by 768, that's still plenty of space. That's 1 million pixels. So space is seldom an issue for desktop computers because, well, they have relatively large monitors. But it's going to be an issue for mobile games because even though a mobile device's screen has about as many pixels as a comparable desktop monitor, probably even more, the problem is the screen is still physically small. I'm going to have to talk about what I mean by main view and UI elements, because there is one famous example that comes up when I talk about balancing the main view and other UI elements. And that is RuneScape. I'm just going to have to draw the interface right now. So, before the days of RuneScape having the modernized game interface that we have to work with, and I guess I'm technically talking about both RuneScapes here because there's a RuneScape 3 and an old school RuneScape. If you've played RuneScape back in the day, and I mean like 2000, mid-2000s, you're probably familiar with the following interface. So here, I'm going to draw a rough sketch of what the UI looked like at that time. So this is the main view. It's the view that the player sees of the game world. And it takes up only a small proportion of the screen. Everything else is just UI elements. So this is where the minimap would be, which contains indicators such as the player's health, the player's prayer points, the player's run energy. Down here is the game's interface for the player's various menus. Inventory, skill interface, quests done, prayers available, and the logout interface is there as well. And then finally this block here, that's the chat interface. So this is what I mean by a user interface trying to balance space devoted to the main view. So this is the main view. So you have your player here with an axe. And a tree stump that he just chopped down. There we go. So yeah, this is the main view. And then everything else is just UI elements. So this is what I mean by balancing main view, and UI elements. For both RuneScape 3 and old school RuneScape, well, for old school RuneScape, you still have this option of going with the old school interface. But in both games, for both games, the main view takes up 100% of the screen, and everything else is just superimposed on it. In other words, this basically means the reason why this exists is because yeah, we just moved on from small interfaces like this. So this would only fly for small monitors, but now we have really large monitors. So playing in this cramped of a space is no longer desirable, and now we can just get away with having the main view take up the whole screen and just placing everything else on top of that. But even then, you have to balance that. Okay, let's go back to the slides. Right. So, telling the player what they need to know. So, that includes stuff like the player's health, the player's mana, the player's cash. And what information you need to display is obviously going to depend on the game. So, you can refer to these 4 slides for guidance on what to display to the player in terms of what does the player need to know. But even this may depend on this may change depending on what your game requires, and also what gameplay mode the game is even in. But once you have all that critical information, can you then move on to optional information? So stuff like this. No, actually no. As you progress, you're gonna want to keep these general principles in mind. Be consistent, give good feedback. The player's in control. Limit the number of steps needed to control an action unless it's part of a combo move. Permit easy reversal of actions unless that affects game balance. Minimize physical stress on the player. Don't stress the player's short-term memory. Group-related screen-based controls and feedback mechanisms so the player doesn't have to go scanning around the screen just to find them. And provide shortcuts for experienced players. These are just some general principles that you're going to want to keep in mind as you make your game. So these are the things that the player wants to do. Devise an appropriate control mechanism to initiate every player action that the player wants to take and how that affects the game. And refer to these slides on how to get started. You're going to have to map your device's input buttons to the player's actions based on your chosen interaction model. But there's too much variance here on what kind of input devices we're dealing with. We have joysticks, game controllers, touchscreens, keyboard and mouse, and so on. So the best thing you can do is study other video games in the same genre and see how they use different on-screen buttons and physical devices. I'll tell you right now, the most common thing that you may see in a lot of video games for desktop games is WASD for movement. And this is for movement across a landscape. If we have movement in 3D space, like outer space, that could be extended to include Q and E for rotation. I've only ever seen this once in Space Engine, where you have WASD for your 2 dimensions of movement, but then you also have Q and E. But I think it also may be extended to additional keys for roll and up-down movement. Oops. And when it comes to desktop games, you also have the mouse. Of course, the mouse is the mouse. you gotta know which is the left mouse button and right mouse button, because for accessibility, sometimes people will swap the left and right mouse buttons. This is a right-handed mouse, and for example, left-handed people might want to swap the left and right. Oh yeah. Also, shell menus. So shell menus allow the player to start, configure, and otherwise manage the operation of the game before and after play. One type of menu may come to mind, and that is the main menu. It's also among the very first things the player will see, unless there's an opening cutscene that plays before you're greeted to the main menu. So, be sure to give a good first impression on the main menu. The only game I can think of that does not start at the main menu, if we exclude games that start at an intro cutscene, that's called a shell screen, by the way. If you exclude those kinds of games where it starts with an intro cutscene, the only game I can think of right now that does not have the player start at the main menu is Prison Architect. And I actually have that game in my Steam library, so be right back. Okay, so I just had to reinstall Prison Architect for a moment. Off screen on a different monitor, I had just clicked the play button. I'm gonna play Prison Architect, and I'm gonna see. Okay, that's just the installer. We have to wait a little. Let's see. Oh, okay, get started. And, okay, maybe a bad example. I don't want to go through this process right now. But, unless it's changed since I last played, which has been several years, the game just starts. I'll just describe what it looked like. The game starts off, you just start off at this basic prison. Prisoners are already coming in. Workers are already being dropped off. That's the start of the game. I cannot think of any other game that does not start off at a main menu like that. That's the only game I can think of where it just drops you off already in a world. Anyway, let's get back on track. Because the more complex a game, the more stuff is gonna have to be displayed on the screen. To the point where, is this even a video game anymore? So, the more powerful machines have become, the more complex games have become. And with more complex UIs as well. If you don't manage this complexity, you might end up scaring away players. So as a first resort to managing this level of complexity, simplify the game. This is done through two different things, abstraction and automation. So abstraction, oh, and by the way, that game was World of Warcraft. RuneScape is no exception to this. I've seen players' interfaces be like extremely complex. I try to be in the middle of the 2007 RuneScape user interface and that extreme. I tend to be somewhere in the middle of those two extremes. So abstraction, we talked about abstraction as part of the abstract versus representational dichotomy in video games. This is where we make the game less accurate for the purposes of making the game easier to play. So some driving games just don't have a fuel gauge at all because it's just not part of the challenge. But again, that depends on the nature of the game. But even if your game, even if your car-related game requires a fuel gauge, maybe you'd want to simplify fuel consumption. Because fuel consumption is something that is affected by several different factors, such as road conditions and driving habits. We can just simplify that by having the fuel drain at a constant rate. Automation is where a process that would be handled by the player is handled by the computer instead. This is not the same as abstraction because this process is still part of the game. It's still part of the game, and the player doesn't have to worry about it. Unless the player wants to do one better than the game. So Prison Architect is yet another example of automation, and to an extent, also RuneScape. I'll just show you what that means in a little bit as well. So seasoned players might actually want to automate the process themselves if doing so yields a better result. If this is the kind of complexity you want, have it be toggleable. Call it something like beginner or expert, or automated and manual. You can even have automatic mode be just good enough, so players who don't want to bother just won't have to bother, and experienced players will be able to just basically do everything themselves. And again, RuneScape 3, specifically its combat system, which is a pretty divisive subject in and of itself, and I can see both arguments. People like the simplistic combat system of old school RuneScape. At the same time, many people actually adapted to the new combat system. I am somewhere in the middle of those two extremes. So here's what I mean by the combat system. Okay, can you believe it when I say I'm actually playing RuneScape as part of the lecture? Anyway, I'm just gonna pick out some equipment that I can use for demonstration purposes. I'm just gonna go with, let's go with this preset here. Actually I have to, so this is what I mean by automation. So, RuneScape 3's combat system, if you are not in the know, it is an ability-based system where you have to activate certain abilities to perform certain moves in combat. This fills up your adrenaline bar, and when it fills up all the way, or to a certain amount, is when you can perform more powerful moves like this. This is what I mean by automation and doing things manually. Because again, I'm in the middle of those two extremes. I don't want to worry about activating the most basic of abilities myself. But I do want to have control over when I activate the more powerful abilities. Like that. Again, more experienced players, they go and some of them swear by activating every ability themselves. Which I understand, because I can understand that it provides a better result. But again, I'm not like those players, so I just stick with what works, probably to a fault. So, yeah. This is what I mean by automation. So the game is automatically selecting certain abilities for me, and I only intervene when it comes to activating certain powerful moves. So yeah, that's automation. I think we can stop this now. Okay, go back. Oh yeah, I'm also level 99 in everything, and have been for the past few years, actually. Oh, Shooting Star is available in 5 minutes. Well, can't do that right now. Also, Prison Architect is a very good example of automation. So you can place down prison guards in certain areas of your prison, but you can also define prison routes for them to take. Micromanagement is something that you can unlock in the game's own tech tree, so you can get even finer control over all the processes that go on in your prison. Okay, let's also talk about depth versus breadth. And yeah, RuneScape is also a good example of this depth versus breadth dichotomy as well. So depth versus breadth, that refers to how complex your user interface is. The more options available on the screen, the more options offered at the player at one time, the more you risk scaring off the players if they find complex UIs intimidating. Hold on. So if your UI has many options available at once, that's a broad interface. If your UI has only a few options available at once, that's a deep interface. So RuneScape's a good example of what is called a broad interface. Like, basically, everything available is already available for the player to look at. And some players actually like this because once they find out where everything is, it's easier for them to find it again. Devoted players may find this to be more efficient than a deep interface. You see it typically deep interfaces with mobile games because, well, they don't have enough screen real estate to put everything at once. So this is Pokemon Go. This is a good example of a deep interface. It takes several button presses to go where you need to go in the menu interface, and sometimes it's tricky to even find it. But once you do, it's not that hard to figure out, but even then, it takes several rounds of navigating just to figure out, okay, this is how I select a route to follow. If you can, provide both a broad interface for experienced players and a deep interface for new players. If you can't do that, make something that's a balance between broad and deep. Oh, context-sensitive interfaces. Hold on. Ever seen games where the cursor changes shape when you hover it over certain objects? Or, say in Word, certain options are grayed out because you got the wrong thing selected. Or the user interface changes because you selected an image and you want to edit that. That's a context-sensitive interface. And the best example is when the cursor changes shape, depending on what the cursor is hovering over. Say you hover the cursor over a log, and it changes into a fire icon, indicating, do you want to light this log on fire? To start a fire. Or you hover it over a tree, and it changes into an axe, and the options available are chop down the tree. Or you hover it over a rock, and the options become mine and prospect ore. These kinds of interfaces reduce complexity by only displaying the permitted actions that can be done to the currently selected object, and it's also a great way for the player to learn about what actions they can do. Oh yeah. Also, one thing to talk about is obscurity. It's possible to overdo UI features to the point of making it hard for the player to use. If this happens, you have an obscure interface, so beware of the following things to avoid obscurity. Artistic over-enthusiasm. Sometimes artists make UI elements that look elegant, but they don't convey any useful meaning. Also, pressure to reduce UI screen usage. Icons help to reduce text use, but the more complex the icon, the harder it is to understand. And also, developer familiarity. You, as the developer, know what the icons means, but you can't say the same thing for your player. But that's what playtesting is for. If the players can figure out what those icons mean with very little difficulty, then those icons are good. If people are still trying to if people have played it for a few hours and they still can't figure out what those icons mean, then something's wrong. And I can provide one, maybe two examples of what I mean by icons being weird. I'll be right back. So one symbol that I always remember seeing in the gauge cluster of the family minivan is this symbol. I'm going to do my best to try to recreate it. It looked like this. That symbol is coolant temperature. I always thought it was a sailboat. Meanwhile, my computer science professor that I had as an undergrad had a similar problem with a completely different icon. It basically looks like a Greek temple, and it looks something like this. That's car radiator. So we had the same problem of obscure icons. I thought this was a sailboat, and then my professor, Dr. Gomez, had this problem. So that's the problem with using icons. Yeah, they reduce screen usage, but they reduce text usage, but up to a point where the icon just looks too obscure. Like squint your eyes and tilt your head. Yeah, that really looks like a sailboat, doesn't it? But yes, all icons are good, but then up to a point, it just becomes hieroglyphics, basically. But even hieroglyphs can convey meaning other than what the thing is supposed to look like. Sometimes they can convey sound, and now I'm talking about writing systems. Anyway, going back to game design right now. Okay, let's talk about interaction models. So, once you see what interaction models are, you're gonna think to yourself and say, oh, this makes sense. Oh, okay, so that's what's going on. So the interaction model is the relationship between the player's inputs via input devices and the resulting actions in the game world. And again, you're probably going to be familiar with a lot of these, such as the avatar-based interaction model. The player controls an avatar in the world. You perform actions. You do keyboard inputs, and it translates into actions that the avatar, can do in the world. Click the mouse, the player swings his sword and basically kills the mouse. Here's the multi/omnipresent interaction model. The player acts upon several different parts of the game world at a time. This is also accompanied with a top-down aerial view. And this game is called Shapes with a Z. This is a multi-present interaction model where the player can just move around, interact with anything freely. The party-based interaction model is typical with some types of RPGs where you control a party of NPCs and you can command them to do certain things. This also typically uses a aerial camera model as well, though it doesn't necessarily have to be. The consistent interaction model is basically the kind of model used by games such as Kahoot. The desktop interaction model mimics some sort of computer desktop interface, and it's used in games that simulate an office activity, though at this point I would also probably add Cookie Clicker to this, because those are the kinds of games that do not have a camera model, because there's nothing that requires a camera model. There's no game world to speak of. In Cookie Clicker, there's no game world to speak of. You just have this interface where you select things, click the big cookie, make cookies. Okay, for camera models. So for older games, the game screen was just treated more like a game board. But these days, we talk about games having a camera like it's cinematography. Video games have a virtual camera, and how that camera is used is called a camera model. Oh, by the way, we have to talk about filmmaking terminology. If the camera moves forwards and backwards, it dollies. If the movement is side to side, it trucks. Maybe if I toy with my camera, my webcam, if it moves, okay, so if it moves side to side, it trucks. If it moves forward and backward, it dollies. If it moves vertically, it cranes. If it rotates about a vertical axis, like this, it pans. If it rotates about an axis that makes it tilt up and down, it tilts. And if it rotates about an axis that goes through the lens, it rolls. Okay. Early on in the process of thinking about what your game should be, you had to answer the question, do you want your game to be 2D or 3D? First-person and third-person perspectives typically require a 3D engine. Most large games are also 3D. Smaller games are typically 2D, but with modern hardware and modern software, the decision to go 2D or 3D is basically a decision that's contingent on your art team's skills and aesthetics of your game and the time you're able to devote to your game. It's also for mobile games, it's even more pressing because the hardware of a mobile device typically is not as powerful as a comparable desktop computer, but even today we now have gaming phones, by the way. So maybe that gap is closing after all. In general, go 3D if you can. If not, make a 2D game instead. Good 2D is preferable over bad 3D, and also bad graphics are the very first thing that a player will notice in your game. Okay, now we're going to talk about camera models. And again, a lot of these are going to be self-explanatory. First person perspective. The camera is where the player avatar's eyes would be. You can't see the body of the player avatar, which might be one less thing to animate. And wherever the player moves, the camera moves. So this is great for immersion. You don't need any special AI to move the camera either. It's also easy to aim ranged weapons with, and it also makes interaction with the environment easier. But it has a few disadvantages, such as those related to motion sickness. You can't see your avatar's body. You can't see your forehead. You can't move the camera for dramatic effect either. Then we have what is called the third person perspective. Here the camera is positioned somewhere behind the player avatar, and it looks down on the avatar. So RuneScape is also a great example of a third person perspective game. The position behind the avatar assumes that any threats to the player will come from the front, but if the camera is positioned from the back, you also have a good view of any threats that would come in from behind. For these kinds of games, you also want to be able to move the player and the camera possibly independently of one another. Also, there are some considerations for how does the camera move when the player moves. So you have several options for when the avatar moves. Well, when the avatar moves, so should the camera. That's pretty straightforward. Sometimes the camera might lag behind and then eventually catch up. There are certain ways to code for that. When the avatar turns, you might not want the camera to turn exactly with the player avatar. Maybe you want the player to turn and then the camera to turn afterwards. There are several ways to do that I won't be getting into great detail here, but I'm gonna say there are several challenges and options for how to move for when it comes to moving a third-person camera. Also, when it pertains to when the player is up against a wall. If the player is up against a wall, then the camera might not be able to view the player properly. In those cases, you might want to make the wall semi-transparent or have the camera move totally upright, or possibly transition from a third-person point of view to a first-person point of view. And again, for third-person games, you may want to have separate controls for the player avatar and the camera itself. Legend of Zelda and Tears of the Kingdom are pretty good examples of this. Controlling the avatar and camera independently of one another. So here are the camera models associated with a top-down perspective. These are the camera models associated with a third-person camera. So we have the top-down perspective, basically exactly what it says on the tin. It's a bird's-eye view of the whole game world. It's limiting if you have a more powerful machine available, and when it comes to buildings, you can only see the tops of buildings, not the sides. Unless you go for an isometric perspective. So this is also a way that older 2D games faked being 3D. This also distorts farther objects in the distance. They appear larger than they should, but for many players, this is a non-issue. For the SimCity games, up until SimCity 4, it was an isometric camera. or I guess more specifically, it's an orthographic camera. Orthographic projection, I should say. It means in these kinds of games, you're limited to those camera angles. You can move the camera, but you cannot rotate the camera. And if you do, you'll break the illusion. There's also the option of a free roaming camera, but there are several disadvantages. The player has greater control over where the camera can go, but it has a disadvantage of now you need art assets everywhere the player needs to go, and the player might get lost. Oh yeah, just how we can have a context-sensitive UI, we can also have a context-sensitive camera. And if you want a good example of that, look no further than the intro cutscene of The Legend of Zelda Breath of the Wild. I'll leave it to you to watch that in your own time. Yeah, there are some other options for other games, such as a single-screen game where everything fits on just one screen, a side-scrolling game, or top-scrolling game, which is more or less the same thing, but the only difference is which way is the world going. And now we talk about visual elements. Whichever camera and interaction model you choose, you still need to supply the player with information using visual elements on the screen. So the first thing is going to be the main view. I talked about this with the RuneScape interface. Usually, the main view is going to take up most of the screen's space. And unless it's like old school RuneScape's old interface, like 2007 and before, most games are going to have UI elements superimposed on the game view. Very few games, and this would include RuneScape 2007 and earlier, few games have the main view surrounded by panels with supporting elements. Now we're going to talk about feedback elements. These tell the player details about the game's inner states. What is going on? How is the player doing? What is selected? What is the current task? And so on. So, indicators inform the player about the status of a resource graphically and at a glance. Whatever indicators you use, make sure they are appropriate for the theme of your game. So a lot of these are basically UI elements, and a lot of them are self-explanatory. So we have digits used to display numeric values on a screen. Not suitable for everything though. You have a needle gauge, which displays a numeric value like the odometer of a car. In fact, this is perfect for a racing game. We have a power bar, which visualizes a numeric value as a long, narrow-colored rectangle that shrinks or grows based on the current value. You may know this as a health bar, but it also works for non-health values like mana, stamina, and so on. You can also color-code it based on the context, so it's green if the player has high health, and it can turn red if the player has low health. Oh yeah, you can also decorate the health bar to fit the theme of your game. Colored lights can be used to convey symbolic information. Similarly, we can also color the health bar based on context, though this has some accessibility issues with colorblind players. Icons convey symbolic information in a way that text cannot. They're also space efficient, and some icons have different meanings in different contexts and cultures. Don't use too many icons. Not everything can be represented with an icon. I'm looking at you, sailboat coolant temperature reading icon. And make sure your icons are appropriately themed. Text indicators also convey symbolic information in a way that icons cannot. The only issue with using text is if you are to sell your game internationally, you gotta localize the text. A minimap, sometimes called radar screen, shows a miniature version of the game world top-down. And color. You can show more information on a numeric or iconographic element by coloring it. So green is used, you can color a health bar green to indicate this player has high health, and then color it red if the player has low health. Again, this has the same this has accessibility issues for colorblind players. Screen buttons and menus allow the player to control processes too complex to manage with controller buttons alone. I'm talking about UI elements on the screen. In some situations, you have to use your input devices to press a specific button on the screen to do a specific task. Most of us should be familiar with these kinds of elements since we see them all the time, but it's a good idea to not display too many controls on the screen at once, unless your game is actually supposed to emulate a desktop computer's interface. Also, these buttons, deem them to fit your game also. When it comes to text, most games have a fair amount of text, and it's either used as a feedback element, say displaying the text of what you need to do next, or displaying the text of a status effect on you. Say you got blindness for 10 seconds. Of course, text has multiple uses, such as the textual description of weapons, vehicles, dialogue. The one thing you need to know about text is if your game is to be sold in a different country, different from the one you were originally making your game for, it's necessary to localize the game. This involves translating the game's text and voiceover dialogue, and also requires many changes to the game's software and content of the game. I'll tell you right now, translations are not one-to-one. A famous example I can think of is when you drop your phone in water and you're told to put it in rice. In Tagalog, what kind of rice are you talking about? There are two words for rice in Tagalog, and one means cooked rice and the other means uncooked rice. So there are tales of Tagalog speakers putting their phone in cooked rice. Even if you're selling your game to the UK, or you're a developer in the UK and you're making your game available to the US, there's gonna be tons of spelling changes you're gonna have to do. Like color with a U becomes color without a U. Or, did you know that in the UK they number buildings floors starting at 0? So what we call the first floor is called the ground floor. The US second floor is the UK's first floor. It all starts at 0. If you're going to localize your game, keep all the text in your game in their own text files, and don't embed text in a picture or the game code unless that text is part of the picture itself. Okay, typefaces and formatting basically make your text readable. Also, know the rules of good typesetting and use fonts designed for reading on a screen. Also know when to use uppercase and lowercase appropriately. Uppercase, for example, looks like shouting, emphasis, or urgency depending on the context. Also, choose your fonts, or technically typefaces, with care so that they harmonize with the game. Don't use too many fonts. Be aware of the difference between display fonts, such as Impact, serif fonts such as Times New Roman, and sans serif fonts such as Arial. Know when to use and not to use monospace or fixed width fonts. Sometimes that might look a little out of style unless you're using this kind of text specifically to look like typewriter. It came from a typewriter. One thing that came up between when I first learned about user interfaces and now, many fonts have fixed width numbers now. Back when I was making user interfaces in Visual Studio, back when I first learned about this, the one trick that I was always taught is to use the number 8 as a placeholder digit, because that was the widest digit. I don't think you have to do that anymore if you have the right font. So if you have rapidly changing numeric values on your screen, you don't have to contend with rapidly changing width of the text. Now we're talking about audio elements. So these include sound effects, music, and if your game has it, recorded speech. And your programming team should also keep all of these in separate files. Also allow the player to adjust the volume of different audio elements. So sound effects, this is the most common use of sound in a game, and they correspond to the actions and events of a game world. Even if it's as simple as clicking the button of a menu screen. You can also reinforce visual feedback with audio feedback. Whatever sounds you choose, they should harmonize with the rest of your game. The one example I always like to go with is swinging of a hammer, you expect the sound of metal on metal. What does it mean if you do that and it's a fart sound? If you have a single sound effect repeated over and over again, it might start to sound fake and boring. An easy way to fix this is to pitch shift it or have different variants of the same sound selected at random. Minecraft's a good example of this. There is the sound that you get when your player gets hurt. It's a sound effect in older versions of the game, but again, this is a very cheap and easy way to make it sound like your sound effects are not repetitive. Pitch shifting the sounds. So if you're getting hurt really fast, it's if your game's controls have this, you can also use vibration. Don't overdo it, or else your player's hands will feel tingly. Ambient sounds. Give the player aural feedback. It makes the game more immersive, but don't overuse ambient sounds, especially in games that feature mental challenges. Music also helps to set the tone and establish the pace of your game. You expect fast-paced music in a game. Also, I'm gonna pick on RuneScape again. There's at least 1,000 soundtracks in RuneScape, and it's probably got the world record for most soundtracks in a video game. Music also sends a cultural message, so use something that fits your game. Music doesn't have to support the game at every moment. Just choose music to create a contrasting effect at times. Also, Minecraft has this unique thing going on with its music. It plays randomly at specific times, and the meaning behind those soundtracks, there is no meaning. This is what fascinates me about Minecraft and music composition. What if you make a soundtrack that is meant to have no one specific meaning? The meaning of that piece is whatever people assign it to be. That's something that fascinated me to no end. Also, if we're talking about voice-over dialogue, just about any kind of game can use spoken material to provide information. Just beware that repetitive spoken content rapidly becomes tiresome, and the longer the sentence, the worse the problem. Also, the writing and acting must be good. Okay, there's some terminology regarding input devices. We talk about a neutral position for a joystick, but a mouse doesn't really have a neutral position. You also have devices that can return two specific signals on or off. We call that a binary device. And the opposite of that is something that returns a signal along a continuum. That is an analog device. We also have dimensionality and so on. I'll just leave it to you to read all of this. I don't think I'm going to dwell too much on all of this, unless you're making a game that's meant for a video game controller. I'm going to assume that your games are going to be made for a desktop computer, so a lot of these might not necessarily apply, so I'll just breeze through it real quick. Okay, so 3D input devices. These are once rare, but we see them in the form of smartphones and console controllers. Basically, they have accelerometers and GPS. You have your two-dimensional input devices such as the D-pad and the joystick, and you also have the mouse, which returns the XY coordinates relative to where the mouse is. You convert that to absolute values to denote where the cursor is. There is no neutral position, unlike a D-pad or a joystick. You also have touch-sensitive devices like a touch screen. Those can register more than one touch. You also have 1D input devices. These send a single value to the game, which is going to be either on or off, or something in between if it's an analog device. So you have binary, and then you have analog. And a lot of these buttons do all sorts of things. Even if it's simple as pressing the A, B, X, or Y keys on a controller for a game console. Navigation mechanisms tell the player how to move a character, vehicle, or other mobile unit around. The most two common steering mechanisms are screen-oriented and avatar-oriented, though other mechanisms also exist. Again, I'll be pretty quick about this. Screen-oriented, when the player moves the joystick, the avatar moves towards the top of the screen, used for when the camera model is fixed or free moving and does not follow the avatar. Avatar-oriented, when the player moves the joystick, the avatar moves forward. This works best with camera modes in which the camera follows the avatar. There's also flying. Though this requires movement in 3 dimensions, if using a joystick for 2D movement, you need some separate mechanism for your third dimension of movement. So that would be WASD, and possibly another set of controls for up, down, and roll. Fixed-wing aircraft, for example, use the joystick to pitch or roll the aircraft. Helicopter navigation is typically simplified in video games, but usually there are controls for 2D movement coupled with a slider for ascending and descending. So this is what I mean by WASD, and a third set of controls for up and down and possibly roll. Point-and-click navigation. In a multi-present or partly present interaction model, the player chooses a unit to move and then selects a destination for that unit to go to. So, yeah, point and click, exactly as it sounds. If applicable, you select a unit to move, or if it's your avatar, you skip the step. You click somewhere in the game, and the player or NPC moves to that location. Now we talk about accessibility features. Per the textbook, and keep in mind this is an old text, Microsoft leads the world in making their products available to people with disabilities, and the game industry should do what they can to make their game accessible to other players. There are considerations for players with low vision or players who need magnification, and even colorblind players. By that I mean, ever played any of those match 3 games like Candy Crush? The easiest accessibility feature that you can ever add to that kind of game is to make your shapes distinguishable by both color and shape. In any case, provide both audio and visual cues for the same event. For players with low vision, offer players a high contrast user interface as well as the option to change brightness. Recently, Minecraft has had a high contrast UI implemented, and people gravitate to it because it basically looks like if Minecraft had a dark mode interface. Okay, so high contrast mode doesn't work in all cases, such as people with macular degeneration, so you're gonna need to do some research to make your game accessible in that regard. If you wanna go that route, the text recommends Lighthouse International and the Wilmer Eye Institute at Johns Hopkins University for further information. For those who need magnification, that's pretty simple. Just change the text scaling. Often you also need to change the ability to... Okay, so for players who need magnification, oftentimes it's as simple as changing the scale of the text and possibly the UI itself. Also, you may need to rethink your user interface by making it less broad and more deep. For colorblind players, keep in mind that colorblindness affects about 6% of the male population, so that is a non-trivial number of people who are colorblind. Don't rely on color alone to distinguish between game objects. If possible, make them distinguishable by shape as well. If you have traffic lights, for example, where the light is illuminated is usually enough to tell, unless it's a sideways traffic light. In which case, where does the green light go? In either case, yellow is always going to be in the middle. So, traffic lights are standardized so that red is up, yellow is in the middle, and green is down. However, if this is a railway signal, green is up and red is down, and yellow is in the middle. This is a holdover from when railway signals were just balls on strings. For hearing impaired players, consider displaying visual cues for audible events, like a gunshot showing a muzzle flash, for example. Though you can't always do this in all cases, offer separate controls for sound effects and music. If you can, also do that for spoken dialogue. If your controller has a vibration feature, and I guess this is if you're making a game that even has a vibration feature on its input devices, use that for feedback, and also offer subtitles. For mobility, reduce time pressure needed to accomplish certain tasks. If you can, adjust how fast the game operates. I guess it's more applicable if you have a game that's a simulation game, and you can control how fast or slow the game operates at. Also, keep your game's controls simple. If your characters have an idle animation, don't avoid having a judgmental looking idle animation. And for older players, you're referred to sprite.org. Also, for allowing customization, that includes swapping the left and right mouse buttons. For touch screen devices, that also includes switching handedness, swapping up and down directions on the mouse and joystick, and my personal favorite, allow the player to reassign keys, especially if there are certain keys that they can't otherwise reach, or they use a different keyboard layout. So yeah, that's about everything there is in this book, or rather in this chapter. The last one is when you have accessibility features that are used by the wider public. That's called the curb cut effect. When accessibility features benefit those who don't need, so when you have accessibility features that benefit more than the expected group of people. So, wheelchair ramps. The expected use is for those using wheelchairs to go up and down a slope. But it's also useful for those who have to lug a cart up and down a slope also. Also, an elevator. Your typical elevator is also an accessibility feature for those who can't go up and down because they're in a wheelchair. But also, there is yet another accessibility feature in your typical elevator. And this might sound a life hack. This might sound like a life hack if you've never heard of this before. 1 ding is up, 2 dings is down. There you go. So, common accessibility features that benefit all sorts of people are captions, also text-to-speech, and to an extent, or maybe not, dark mode. So yeah, that's everything that I have to talk about in Chapter 12, how to make the user experience. This includes discussions on what a camera model is and what an interaction model is. A lot of that is self-explanatory, and a lot of it is just knowing what and how to design your user interface so the player has a good, enjoyable time playing your game. Eventually, I'm going to have to cycle back to the other chapters, storytelling, characters, and level design as well. But again, I might just have to make that a bonus video. Alright, that's going to be it for Chapter 12, and yeah, guess I'll see you in the next video.